Please welcome panel moderator, Chief Technology Officer GE, Vic Abate.
So good afternoon. How's everybody doing? You know, a great day here in New York City. Listen, we've got an exciting panel here, and I'm really excited to hear from them. We've got a topic of the future of additive. And so what I thought I'd do is let's just start out before we start talking about dreams and tomorrow with grounding us on where we are today. So I'm going to have our panelists introduce themselves, give a little bit of their background, because I think we've got a diverse panel from different perspectives that can help shape a full view. And then tell us a little bit about yourself and where you see additive today and some of the challenges.
Great, thank you. My name is Wayne King. I'm from Lawrence Livermore National Lab. I've been at the lab for about 30 years or so. The lab got into additive about 2011, and you might say, well, what's a Department of Energy lab doing in additive? Well, we're a subset of the DOE, a semi-autonomous subset of the DOE that's made up of 3 labs and 4 plants, and so we actually make parts. And when we get together to talk about additive, we have about 200 people that are working in the area. So it's, we're all in the additive area. When I think about where we are today, I think back to a presentation I heard from Airbus in December, where they were talking about the additive process chain and the fact that from the design all the way to the disposition of the part, it's a long and tortuous path today. And this seriously relies upon an experience base to be successful. And that's a real problem as we see it.
So when you used a key word there, torturous. And I think as we talk about the future, that's got to be a big part of the transformation.
Exactly.
So our next panelist, Ralph, maybe just some of your thoughts and your background.
Sure. I've been in the manufacturing world for longer than I want to care to admit. But I had a Audubon moment about 25 years ago when I walked into the basement laboratory at MIT of Professor Ellie Sachs, and I saw a 2-inch scale model of the Hagia Sophia that was done by 3D printing in alumina. And that's where I had my wake-up moment to additive manufacturing. And so my small company, where I was the chief technology officer, Extrude Hone, we were the first licensee of that technology to binder jetting for metals. And then that company, we spun off to form X1. So I went on to join the National Center for Defense Manufacturing and Machining about 8 years ago. And 6 years ago, we won the contract to establish the first Manufacturing Innovation Institute in the US, and that is America Makes, which is focused on additive manufacturing. So as Wayne said, this tenuous route, tenuous and tortuous route that we have to go to be able to bring products is something that America Makes is working on. Being able to establish through a collaborative private-public partnership, addressing those issues and trying to accelerate the insertion of additive manufacturing. So, and that can only be done, as we've heard before, by partnering both with the equipment providers, the universities, the labs, everyone that's within the community, and addressing those issues that we can as a community.
All coming together as a total ecosystem.
So
thanks, Ralph. So Steve Duclos, who's a partner with me up at the Global Research Center for GE. Steve, some of your thoughts, and maybe just introduce your background, because you've been doing this for
so I'm Steve Duclos. I'm chief scientist at the Global Research and working in the additive horizontal, which goes deeply into the technologies in additive, but also works across our businesses to bring additive technologies across GE businesses. You know, we're talking a little bit here about some of the where the ecosystem stands today, and as I look at it, there's a couple of things that are kind of creating constraints to the ecosystem. One of them is the upfront design. It just takes so long to develop a design that becomes manufacturable. And that involves a lot of iterations on builds. So there's that constraint. And then there's also, we've heard earlier today around constraints on size. And as soon as you start building large, you realize that there are also some constraints on build speed, all of which ends up relating to cost. So my sense is today there's lots of great things happening in manufacturing. We're doing great things in aerospace and healthcare and power. But really, we have to work towards getting rid of some of those constraints.
And that's a good lead in. So when I think about the constraints, I think about how do you industrialize additive, right? How do you make it where it's much more of a natural push button process as opposed to an innovation along the way dimension. So maybe back to you, Wayne, if you think about industrialization and you think about the work that you're doing at the labs, how do you see that as an opportunity to go forward? I mean, if we don't get that, can additive become what a lot of people talk about?
So our big challenge is qualification and certification of critical parts. Right now we can print parts quickly, but we have to qualify them and certify them in the same way as we have done historically. And really that's an unacceptable answer for us. So we need to come up with a way of shortening that process, making it much more efficient so that we can really take advantage of additive manufacturing. And the way we're doing that is through our modeling and simulation efforts, but that's not going to be enough. So I'll talk a little bit about that later.
And Steve, what about digital? When I look at this, especially in manufacturing, it's just such a physical world. But can we move this industrialization platform without a digital over the top and a digital inside fundamental content?
Digital is going to be absolutely critical to the future of additive. The one good thing is it's a manufacturing process that's growing up in the digital age.
Yep.
And the way I look at it is really it's digital upfront, and then it's digital inside the machine, digital inside. And so upfront, going back to what I said earlier around getting the design iterations much reduced, that's going to take understanding the science of what's going on in the builds. It's going to understand it's going to require an intimate understanding of what's going on inside the machine. And so that digital inside, getting the sensors right, taking that sensor data and doing more of a feed-forward controls inside the machine. So digital is going to play a really critical part, both in the design of the part, but also inside the machine.
And understanding the physics. So this is where sort of physics meets information right at the elementary level.
Absolutely.
And so from inside the machine, so Ralph, from your perspective, America makes standards. How does that play in your view? Do we all have to get together and start to really emphasize more a platform of a future set of standards for this ecosystem to become more streamlined?
Right, and it's, the industry has been pretty much the wild, wild west. And that's been good. I mean, it's sparked the creativity and so on. But one of the things that I saw last week at the Rapid TCT show was the maturation of the industry and the sophistication that's growing. Part of that has to do with making sure that we have a strong foundation, that the data that we're collecting has pedigree, and that it has a standard schema that we're going to be testing on. And doing this in a way that doesn't require everyone to be doing make and break tests, so that we can be collectively be sharing that information, because that's really not the competitive data. And so what we've done is there's been efforts that have gone on with the ASTM F42 committee that's been doing great work in building standards, but there's a lot of industry association verticals that are also developing standards. So in conjunction with ANSI, we have brought together over 30 standards development organizations and have put together a standards roadmap that we're all working together towards harmonizing these and building that foundation that we can go forward on so that things are not so torturous.
And how far along are we? I mean, if you think about other industries as they've industrialized, are we still in its infancy, or can we get
I think we've made some great progress in the last 5 years, and I think ASTM is really instrumental in doing that. But I think that there's a ways to go. There's a lot of other standards we can leverage off of. So that's all being worked out in the roadmap and in the subsequent workflow that we're looking at.
Good. So foundationally, I think that gives everybody a sense for where we are, some of the gaps and the opportunities. But if we get the digital right, if we get the standards right as a platform, digital, the technology and the machines and the ecosystem, and industrialize it, what's the future of additive? I mean, how big can this be? What does it look like?
So what we think is going to happen is that I mentioned to you the experience base before, and that's one of the things that's really holding us back. And we think that because additive manufacturing provides us such exquisite control over the process, that we can replace this experience base with a science base. When we replace it with a science base, then we can start using what Steve talked about before, which was called feed forward. If you haven't heard of feed forward before, you can look back at the 2009 Roadmap for Additive Manufacturing by Dave Burrell, where he speculated that feed forward was going to become important for additive manufacturing. And what it is that you use modeling and simulation in some reduced way to teach the machine how to build the part on a voxel by voxel basis. And when you do that, this helps build confidence in the quality of the part when it comes out. Now, I think that this is a really critical technology, and getting this implemented in a commercial machine is important. We know this is going to work. The Germans have already demonstrated it. So it's not like this is a pipe dream. This is something that's going to disrupt additive manufacturing.
And a very significant. Ralph?
I think that we have the potential for revolutionizing manufacturing in general. The opportunity that we have here, as Wayne is saying, is if we look at other manufacturing processes, we've modeled them after the fact, years after the fact. Here we have an opportunity to be doing this in conjunction with our experimental information. And so we have an opportunity to accelerate. It's typically taken 20 to 30 years to see a manufacturing process get into the mainstream. And if we look at CNC or anything else. So the whole idea of the Institute is to accelerate that insertion, to get us through those mid to MRLs and TRLs, and for us to do that, we need to get the simulation and modeling as part of that. And I think what we're also going to see is a revolution, as we've heard previously, of the supply chain. Are we going to be bringing in new people into the supply chain? Are we going to be upgrading people that are presently in the supply chain? But can we indeed be doing manufacturing at point of use? But all of that's going to require an infrastructure, like you said, the digital thread, but a communication infrastructure that's going to be stable, that's going to be fast, that's going to be secure.
Yeah, reliable.
So,
great points. So Steve, what's your view of the future?
So I go right back to where we started, and that is the constraints that are on the ecosystem today. It's a challenge. It can be a challenge to design the parts. This scientific understanding, science-based understanding will go a long ways to making the machines more reliable and more reproducible. That will alleviate those constraints. We're certainly working very hard on larger builds and faster builds. And the standards development. These are all going to be critical to alleviate those constraints. And we are there now, and we are right at that upward curve that we talked about earlier this morning. So additive really is prepped with the scientific understanding, with the standards, and with the digital to be there growing dramatically.
Yeah. And Steve, if you think about all roads lead through a machine.
Yeah.
How important is it to have that, and do you look sort of left and right from there, or how do you see that?
Yeah, you look left and right. I mean, it's going to be critical on the digital side for the software that develops the instructions for the machine to really understand intimately how that machine works, what it can do, what it cannot do, and incorporate that in the design thinking, the design rules that you have for additive. And as we do this, it will greatly enable the machines to build faster and better and higher yield. And then you also look right. Today, parts that come out, there's a lot of processing that needs to happen. We heard earlier about surface roughness challenges and machining that needs to be done. The fact is when you understand the science inside the machine, you can also start influencing those steps that happen post-processing. And so all of this is coming together right now to make these to reduce those constraints.
Yeah, it's interesting when you said too, it's today just with the digital age, you know, that's an accelerator. It's like multiple exponential technologies all hitting at the same time.
Yes.
Really unleash a new future. So listen, we're getting close to the end here, and I'll just do a quick lightning round. So in 30 to 60 seconds, if you had to say, and it's easy if I said in 20 years or something, but I'm going to hold you a little more accountable. In the next 5 years, what's the biggest change that I think we're going to see in additive?
So I think that it's conceivable that we could actually have some implementation of this feed-forward technology that I mentioned to you. And in that, if that is really successful, or maybe I should say when that is really successful, we believe that's going to enable first time right, every time right production. And for us, that's a big deal because we're not going to be making 30,000 fuel nozzles a year. We're going to be making between 1 and 100 parts a year, and everyone's got to be right.
You can't make a couple hundred to get to that first 100.
Exactly.
I think that as we have seen manufacturing get more distributed, and as we've seen the enterprise get extended beyond the factory walls and even beyond the national boundaries, that there's a great opportunity for the supply chain to be significantly revolutionized. And I think that those that are going to jump on board and embrace this technology and get intimately and actively engaged with the community are going to be the ones that are going to benefit significantly. And I think we're going to see a filtering and a change up of the supply chain due to additive manufacturing.
Interesting.
Yeah, and so the technologies that we've been talking about here are really going towards one button print, okay? And when that happens, we're going to see a democratization of manufacturing. We're going to see a distributed manufacturing. You're going to see manufacturers much closer to their customers, and that will enable very many new business models. I think it will benefit products and efficiencies and the like. So that's where we're headed in 5 years. Yeah.
Excellent, excellent. So exciting stuff. I just want to give a round of applause to our great panelists here and thank you for their insights and hope you have a great afternoon. Nice job, guys.